Hello everyone, I'm Lucas Campos and today I'll be talking about the Physics 2212 Lab 1 charge tapes. So in this video today we're going to be talking, I'll start off by introducing the lab and like the purpose of it, moving into the fundamental principles, going into the experimenting calculations into the possible errors, and then the glow script code, and then finishing off with the discussion questions. So, introduction of the lab. The purpose was to calculate the amount of excess charge on a piece of clear tape after using physical principles to induce a charge upon it. And the models and fundamental principles used in this lab is Newton's second law. We have F net equals ma, Coulomb's law. The force is equal to the charges multiplied against each other over r squared times r hat. The gravitational force, which is the gravitational constant times m1, m2 over r squared times r hat, and then we use superposition and point charges. So the actual experiments, some of the assumptions we're going to make is that the upper tape is in equilibrium, the tapes are point charges, and then this also means that they have evenly distributed charges, and then both tapes have the same charge, and then in the systems and surroundings, we have the lower U tape and the lower and upper U tape. And some initial values we have is we know gravity is 9.8 meters a second squared, and that the U-tape length is zero point 0.2 meters, or 0.02 centimeters. So the actual experiment itself, as you can see over here, you you charge the piece of A tape and then bring it up towards tape B to make it float. So it starts here, and then the closer you bring it, it starts to float. And through this, we found that the U tape was positively charged and the L tape was negatively charged. And we also, when my group connected this in the GPS, we found that it floats at approximately 1.2 centimeters. And we found that the excess charge to be 1.688 times 10 to the negative eighth power coulombs. And so that's the charge we found. And then the number of electrons transferred between the tape is 1.09 times 10 to the 11th electrons. And the number of electrons removed from each atom of the tape was 2.776 times 10 to the negative 7th electrons. So the calculations, same thing, length of the tape is 0.2 meters. Mass of the tape from the ratio is 2 times 10 to the negative fourth kilograms. And then we have the separation distance, and the force of gravity is just found from the mg, so mass times the grav times g. And then F electric, which is in this case equal to force of gravity. And then Q, like I just said, is 1.688 times 10 to the negative 8 coulombs. We have the area of the atom here, and we have the width of the tape, and through the width we have the area of the tape, and the number of atoms in the tape is found to be 4 times 10 to the 17th atoms. So some possible errors in this lab is that tape is not actually a point charge, and that also when we're like touching the tape, it's gonna make it lose some charge. It's gonna transfer that charge into your hand or your fingers, and also inconsistent charging of U-tape. I mean, it's not uniformly charged. Okay, so moving on to the glow script code. We have the constants up here along with the objects. We have the system. There's the two spheres, and then there's the sphere and the two arrows. And so we have that, and the results of that is this. So I computationally found the gravitational force to be negative 1.6 times 10 to the negative 3 newtons, and we have all this other stuff here. And like I said, the electric force is the same magnitude as gravitational force. So further questions, some discussion questions is what if what if the electrons had a positive charge and the protons had a negative charge? What would change? Blah blah. So the U-tapes would still repel. The experiment wouldn't change that much. However, finding the sign of a charge would be a different process, as the U-tape would transfer the charges differently. And then why is it important to handle the charge change as little as possible? It's kind of what I just said in the possible errors. Touching the tape too much together can discharge it every time it touches that spot. Every time you touch a tape, that spot loses its excess charge to your fingers because the electrons are transferring. And some of the comparisons between the two is between the code and the experiment is assumed that only two forces act on the system. The electrical force could not fully be vertical. We did not account for loss of charge when touching tapes, and we treated each piece of tape as a point particle with uniform charge in the code. And we do that also in the experiment. So that wraps everything up. Thank you, and have a good day.